Hello everyone, welcome to Leetcode programming. First of all, I would like to thank every one of you for the encouragement so far, for the support so far. It really gives me a lot of motivation to do more videos, and I am really looking forward to that. So the problem for today is, so we are going to discuss today's daily challenge, and the problem is find a corresponding node of a binary tree in a clone of that tree. So given two binary trees, original and clone, and given a reference to a node target in the original tree, we need to find a copy of that given node from the clone tree. So we need to return the reference to the same node in the clone tree. And we are not supposed to modify any of the two trees, either original or clone tree. So we cannot modify them in any way. So follow up, solve the problem if repeated values on the tree are allowed. So basically, right now in the given examples, as we can see, the values are not repeated, so the values are unique in the tree. But if there are duplicate values, so if you let's think about one approach. Let's say you have a tree, the values in this tree are unique, so that way when you are given a target node, you can compare the node value with every node in the tree and find the corresponding node from the clone tree, because you know the node value, then return that particular node. But if you have duplicate values, this approach will not work. If you are comparing with node value, this approach will not work if there are duplicate values. So that's what here it says in the follow-up. Can we solve the problem if repeated values are on the tree are not allowed? On the tree, if repeated values are allowed on the tree, that means there are duplicate values in the tree. So in that case, comparing with the node value will not be a good approach. So let's look at the examples. So as you can see, there will be a binary tree. It will be like original tree. You have a clone tree, so which will be having exactly the same structure. So root will be 7, the left child will be 4, the right child will be 3, and if you take the node of 3, it will have a left child of 6 and right child of 19. The tree structure will be same, the node values will be same. Only thing is the node pointers will be different, the node references will be different. So you will be given a target node, like in this case you have a target node of 3. You need to return the reference of node 3 from the clone tree. So that is our objective. And if you see the second example, you have a original tree of with a node of 7, and in the clone tree the node value corresponding node is again 7 with a different reference, and our target is 7. So you just return the root of the second tree. In example 3, you have again different tree 8654 again you have clone tree 8654 all the node values are same, they are identical, except that the node references are different, and your target is 4, so you need to return the 4 from the clone tree. In example 4, again you have exactly same setup here, both original and clone tree, and the target is 5, so you need to return 5 from the clone tree. Example 5, we have 1 2 3, again 1 2 3. For the target 2, you need to return a reference node of 2 from the clone tree. So looking at the constraints, the number of nodes in the tree will be in the range of 1 to 10 power 4. So obviously we need to come up with a better approach. I mean, probably doing many operations or trying some brute force approach may not be a good idea, considering that number of nodes in the tree are more, and the values of the nodes of the tree are unique. For now, for the current problem, they are saying the values in the values of the nodes of the tree are unique. That means you don't have duplicate values, but we can try to come up with a better approach, considering that even if there are duplicate values, we should be able to, our approach should be able to work. Target node is a node from the original tree, and it is not null, so you will not be given a null target node. So let's see this simple example. So 1 2 3, so we have 1 2 3 and target is given as 2 5. Yeah, target is 2 in this example. So what we need to do is, when you are trying to we are sure that the tree structure is same in both original and clone tree, because it is just a copy of the original tree. Your tree structure will be same, the node values will be same, only the node pointers are different. So if you are traversing your original tree, then if you traverse the your corresponding clone tree in the same way, you will at any given point of time you will be uh, you will be at the same node in both in original as well as your clone tree. So if you plan your tree traversal such a way that you are traversing both the trees simultaneously in the same way, then it is easy for you to find the given node. So what we are going to do is you traverse from the root node from the original tree. At the same time, you traverse your clone tree in the same way, and whenever you find a match with the target from the original tree, you return your clone node. Instead of returning original node, you return the corresponding clone node. So let's say you start from the root of the original tree. If you move towards left of your original tree, then you should move towards left of your clone tree as well. Else, otherwise, let's say if you move towards your right of your original tree, then at the same point you should move towards your right side of your clone tree. So that way you will be at the same point at any given time. So let's look at source solution for both C++ and Java. So we can use either any traversal approach. Probably we can try to use in-order traversal approach using some recursive function. Generally, tree problems are solved best with the recursive approach. So let's try to implement some recursive approach using some in-order traversal. So let's look at Java source code first. So we are having a function get target copy. You will be given original tree, clone tree, then the target node that you need to find. So probably your target node will not be null, and clone tree and original tree will be having the same structure. So just in case if the original tree is null, you just return null, and whenever you find your target equal to original, you return corresponding clone node. That means you are at your destination and you have traversed your original as well as clone trees in the same way. So whenever there is a match with the target and original, you just return your cloned. So that will be your answer. In case if you don't find that, you go to your left, that means you traverse towards left tree, then try to find the value. If you don't find in your left tree as well, then you check for your right subtree. So and then you return the value from the right subtree. So this as I said before, we can use any traversal. So this will be like pre-order traversal, because you are checking the value first, then you are going to left, and then you are going to right. So this is a pre-order traversal because you are processing the node first before its children. So as you can see, as I said before, you need to traverse your clone tree in the same way as your original tree. So if you are going towards your left subtree of original tree, that means original dot left, then you need to go to left subtree of your clone. In the same way, if you are going towards your right subtree of original, then you go towards right subtree of clone tree. Then whenever you find your target, you just return that. So this should work fine. So let's execute and see. Yeah, it works fine. So let's submit and then let's check the C++ solution. Yeah, so solution has been accepted. Let's look at C++ solution. It's same, exactly same, except a few syntax differences. So you have original tree, clone tree, then target node that you need to find. So if original is null, just return null. If your target is equal to original, that means you return the current clone node. If you don't find a match, you go to your left subtree of original as well as clone tree and check if the destination is, if you find a destination, because if you return from here, you will find a destination, then you return your answer. In case if destination is null, in which case you go to your right subtree of original as well as clone tree, then you try to find your target. So finally you can get your answer from the destination, so you return destination. So let's execute and see. Yeah, it works fine. Let's submit and check. Yes, solution has been accepted. Let's check the time complexity details. Yeah, all the test cases have been passed. Runtime of 1 milliseconds for Java, and here runtime of 724 milliseconds for C++. So if you look at the time complexity, and let's look at space complexity. So other than your recursive stack, we are not using any additional space. So if you ignore recursive stack, the space will be in the order of O of 1. And when it comes to time complexity, let's take a worst case. So let's say you are traversing every node. In the worst case, you are going to traverse, let's say your target is the last node in the tree. Let's look at this example. Let's say your target is 3 here. In that case, you are going to traverse 1, 2, 3 nodes. So that means if you have n nodes in the tree, in the worst case, you are going to traverse n nodes. So the time complexity here will be in the order of n, O of n, and space complexity will be O of 1, ignoring space used for recursion stack. So that's it for today. Thanks for watching. Thank you.